So let's get on with it. I'm going to do a short presentation based on one of my lectures that I hold usually at Craft Academy, which is the place where I have my day-to-day job. So let's see if we can get this thing started. I'm actually going to join in here at on Slack, not on Slack, sorry, on my Google Meet, and make the recording both here on Twitch and also using Google Meet. So if we experience any lag or any delays, that's probably gonna be caused by that particular thing. It's the first time I'm doing that particular thing, so it might be a bit problematic, but let's see, let's hope that we get this working properly for us. Right, we should be okay and ready to go. I'm just gonna present my screen here. Let's see. That's the screen I need to present. I just need to send off a text to a fellow colleague of mine. Will be with you in just a second. All right, let's get this started. All right, so I am presenting. Let me just see if I can. Right. There we go. Right. Okay. Let's see if we can make sure that we record that on Google Meet. And now I'm going to wait for the pling and see what's going on here. Right, so here we are, Thomas here, and I'm going to talk to you guys about web technologies. This talk is named or called Web Technologies 101, and this is part one of that presentation that aims to get you acquainted with the basic terminology and some basic stuff regarding web technologies, what it's all about and how we can approach this topic. And the reason why we are dealing with this is, of course, because a basic understanding of the technologies and the lingo used to describe those technologies that concerns the internet as we know it is imperative for all developers to be acquainted with and understand, so that you can progress in your own learning and development as a programmer, as a coder. So Web Technologies 101 part 1, let's get after it and get started. We usually use some quotes in the beginning of our presentations, and in this case a colleague of mine chose this quote: "The only true wisdom is in knowing you know nothing." All of us are using the internet, and all of us has some sort of a relationship with the distributed network and this massive amount of computers and servers and software that makes out what we in a day-to-day language refer to as the internet or the web, for instance, right? But not many of us actually understand anything that goes in, or not much at least, what goes on underneath the hood. And so one of the goals today is to bring some new knowledge to you, and perhaps bring some clarity of what is what and so on. And the following presentation is based on my personal beliefs, but also on the beliefs of people that I've been talking to in terms of what is right or wrong, or how deep we want to dive into certain certain areas, and what is necessary to understand, or at least have a basic understanding of, if you want to work as a programmer later on. And a disclaimer: we do not claim that this is this will turn you into an expert on web technologies in any way. Again, we're scratching the surface here. So if you think at the end of this presentation that why didn't he mention this or that, or he didn't say the entire scope of this topic, or talked about the some of the things in you know, in a depth that is enough for you, that you wish you would have known more, look, there's plenty of resources out there that you can benefit from reading, and go ahead and do that. And if you stick around with us here at Craft Academy, then you will gain more understanding, or deeper understanding of these topics when you progress in the bootcamp, whether you're attending a bootcamp or any of our courses and so on, right? So what I will be talking about in the first part of this presentation is, of course, a little bit about things that concern web application development, a little bit about the front end versus back end, just scratching the surface. But then we're going to dive into some technical stuff like web protocols, IP, HTTP, and URL. And we're going to actually stick around the concept of URLs a little longer, because this is fairly important. We're going to talk a little bit probably about request response, just touch upon this, but that will come in part 2 of this presentation, where we will be also talking about HTTP verbs, query strings, and so on. And we'll see how much I have time for today. I might even code a little bit during this presentation, just to show you some very basic stuff that might prove useful for you. So let's clear out some basic terminology. Now, we often talk about websites, right? And there is a distinction to be made between websites and web applications, but that's a separate discussion. Today, let's just settle for a definition what websites are. And websites, of course, apart from being like a source of information about certain topics, whether it's your favorite restaurant or your community neighborhood, that has something, establishes a presence on the web in order to keep everybody in the loop of what's going on, or whether it's a government agency where you do some business, perform some business, like for instance, here in Sweden, we can call in sick over using our web applications or website. We can claim some parental benefits. We can do banking, of course, as everybody else in Europe and Western world and most of the world. And we can, of course, entertain ourselves. You know, we can book tickets. We can, buy stuff. If we want to buy stuff, we can do that over on websites. Websites are basically, from a technical perspective, a collection of files stored on computers that are called servers. Websites are a collection of files that are stored on computers, and those computers are referred to as servers. Which brings us to, what are servers? Well, servers are computers that are used to host websites, and the servers are connected to this distributed network that we refer to as internet, and they are able to be found using an address or a URL. A URL is something that we will be talking about in more detail soon. But basically, URLs are what you type in into the browser's window, URL input field, or whatever it's called, right? So, which brings us to what a client is, because that's really important. A client are also computers, and they're actually in majority that are connected to the internet, and they are not servers, right? Or they don't act like servers. So for most part, most of the time they are like your own computer, your laptop, like my laptop, or a desktop computer. But it could also be your mobile phone. But it can also be your fridge, to be honest, right? Because there are actually refrigerators now with small computers in them that can consume internet-based technologies. For instance, you can subscribe to some shopping lists, you can do some other stuff, but you can also send off some information to the manufacturer and so on, right? But most of the time, definitely in this context, a client is a computer or a laptop or a mobile phone or a tablet. And then those clients, they also have, there's another aspect of being a client, which is not a hardware part like a computer or laptop, but it could also be a software thing. And one of the clients that we often use in our everyday life are our browsers. And these are programs, pieces of software that you run on your computer or phone, which is the client, like hardware client, and they load the website files via your connection to the internet and shows them to you on your screen somehow. And so you can communicate with those servers that we spoke about earlier and have them send you the appropriate files, and they interpret them and they show them to you in some sort of a form that is appealing to you and brings that the relevant information to you on screen. So website, servers, clients, and browsers. Servers and clients are really important. Servers, they host the websites, and clients, they request those websites using browsers or some other pieces of software. Again, we're just scratching the surface. There are much more to say about all of this. But let's talk a little bit about the front end, back end, full stack terminology. Because if we now know about the server side and the client side, so let's start at the client side. That is something that we often refer to as the front end of a website, and that is generally what the part of that application or collection of files that the users interact with, that is actually visible on the screen, in the browser that the user is currently using. And if we connect that to the craft, we have front-end developers in our industry, and these are the girls and boys, or men and women rather, that build everything that you as a user see when you visit a website. And that is, of course, relevant to the information that is being displayed, but also how it is being displayed in terms of fonts, colors, disposition on the page, when to display data. Should we show everything on one single page, or should we divide the information into separate views and so on, right? So I think that this is the easiest way to describe what a front-end developer does. And I can also just mention that usually they work in three main technologies, and that is HTML, which is the part that creates a structure of a web page that when it is displayed in the browser. CSS, that gives that structure some sort of a look and feel. And then, of course, JavaScript, which it's a computing language, or computer language, sorry, for the internet, and that brings interactivity to the websites and web applications. So front-end developers build everything that you see when you visit a website. Now, a backend of a website consists, of course, of all the actions and all the computing that happens on the server. For instance, how to serve those resources, when to send them out, and how to send them out, but also connect perhaps to a database, perform some calculations before you send out the resources back to the browser, back to the client that requests them. And so in the industry, we have backend developers, which is a specific with a specific skill set that allows them to build and maintain the technology and the solutions and the features that powers the components, so that enables the front end side of a website to exist in the first place, right? So we feed them with data, relevant data. And then, of course, you can talk about the full stack developer, which is, by the way, something that I count myself into. And these people work mostly on the server side of web programming, the backend, but they also speak the language of the front end and often get involved in designing the data flows. Perhaps not the look and feel, the CSS. I usually say that I'm really bad at making things look good. There are far smarter and better people than me that can do that, but I know how to serve data, what sort of technologies to use to make sure that the front end part of our applications can actually access the appropriate information at any given time, and kind of control the data flow from the back end to the front end, and vice versa. So full stack developers work on both the back end and the front end, potentially, and I might eat up those words, but potentially with leaning toward the back end a little more, I would say. Right. So if we take a look at the let's see, if we take a look at the internet itself, how it is being powered, one could say that the most important building block, and there are many building blocks of the, that makes the internet what it is the internet protocol, because it's important to understand the scope and the size of this distributed network. And the internet consists of millions of interconnected machines or sub-networks that allows computers and various other devices to communicate with each other. And the internet protocol, the IP as we refer to it, is the fundamental protocol. And a protocol is basically a set of rules that defines the internet. And without going into too many technical details, let's just say that every piece of data that you are sending over the internet, even as we speak now, or you're watching this stream live or recorded, or however you access this, all my voice, for instance, and also the images that you guys see are transformed or digitalized somehow into ones and zeros, and then broken up into small pieces, almost like a confetti. If you would take a big document and shred it to make confetti out of it, right? And then thrown out through the internet to a specific destination from my server, or rather Google server, because I'm going to host this on my Google Drive and allow you to watch this afterwards, or from Twitch servers if you're using Twitch as a platform. From those servers to your browser, to your computer, or your media streamer, or your mobile device if you want to watch this on a mobile, in the form of this confetti, small packages, 128 bits big, and they travel from those servers, whether they're in the United States or in Germany somewhere or whatever they are, as an uncontrolled piece of information. And then somehow they manage, just before they hit your computer, they manage to align themselves and put themselves together to their original form before they were shredded into small pieces, and then enter your computer through various layers, through the OSC model, and being displayed properly as they were intended to be displayed in the first place, right? So, and that is what the Internet Protocol deals with. So IP has the task of delivering those packets from a server, a source host, to your client, which we refer to as a destination host. And it also deals with finding out where they are supposed to go. So addressing methods are really important part of the internet protocol, so that they end up on the right client at the time where they are supposed to arrive at. Now, another protocol that often comes into play on a different layer of the OSC model is the Hypertext Transfer Protocol, HTTP, which is something you probably recognize if you type in URLs into your browser. You say http:// and then an address, right? So HTTP is a protocol, and that it can be seen as a bridge between the application that uses it and the transfer of data, like documents, media, like audio or video or whatever, right? So HTTP is pretty interesting because it's very simple in its structure, yet the simplicity makes it extremely powerful, and that is what makes the web scale, among other things, but still, right? So it is based on a request response model. So we refer to it as a request response protocol. You basically you request a resource or some information, and then you wait for the response. You request, wait, and you get a response as a client. And as a server, you just wait for a request, and when the request comes in, you deal with it and you respond to it, and then you forget about it, and then you wait for another one. So it's a stateless, often referred to as a stateless request response protocol or data transfer model. So the Hypertext Transfer Protocol is a topic that is extremely important for developers to understand when you're going to build front-end applications, but also if you build back-end applications. Basically anything that touches upon the web deals with HTTP one way or another. There are other protocols that might come into play, but this one is definitely the one that is most important. Now, if we take a look at the Internet Protocol addresses, which is also an important topic, you could say that by convention, all devices that take part in this in a network needs to be somehow identified, and they are provided unique addresses, right? Like human beings, or do you have your personal identification numbers, depending, of course, where you live, but you need to have a unique address. And so that address is referred to as an Internet Protocol address, IP address, or IP number, which is something that you probably heard about. We'll show you an example of an IP number in just a second. Now, the IP number acts as an identifier for a device or server, and can, apart from having an address, also contain several ports, hundreds or even thousands of ports. And ports are like doors into an address. If you take the analogy of a building, so I live in a house and we have a front door, of course, most houses do, but we also have a kitchen entrance, right? So we have two ways into the building, one main port and then a back port, right? And so imagine a building like a server as a building with multiple entries. Again, they can actually be hundreds of them, right? So some of them can be open, easily accessible. Some of them might lead to parts of the server that you don't want everybody into, so they can be restricted and so on. And so because you use those ports for various type of communication or access on that particular server, so you need to be careful with that. And again, this is also a topic where we could go on forever and talk about different use cases and different tweaks and so on. But I think that for the purpose of this talk, we're going to stop there. The ports are important, but let's get back to that topic later on in another session. At this stage, it is important that you do understand that there are multiple ways into every server. And if we take a look at the anatomy of an IP address, and I'm going to only address the version 4 structure, there is another one that, of course, should be mentioned, but again, we're just scratching the surface. An IP address consists of a collection of 4 numbers that are up to 3 digits long. So in this case, we have an IP address of 172.16.254.1, and that is that every series of numbers like those 4, they are represented by 8 bits, which makes the entire IP number 32 bits, 4 bytes. And the port number is usually added at the end of the address, separated from the address by a colon. So one of the most common ports, like the front door, if we take the analogy of my house, is port number 80. It's often referred to as the default port for internet communication, like HTTP addresses, HTTP communication, and it is most often never written out directly because it's a default port. So a server would know that any traffic that comes in, unless there is a port number on it, it should be routed over to port 80. That's as far as I can go on this one at this point. Now, as I said, each IP address can contain hundreds of thousands of different ports, and they can be used for different purposes. I already explained what port 80 does. So when you work as a developer, and often if you look at my demos or my streams, when I develop something, we start a server like a local web server on your development machine, and we are using a local address. And quite often you will see that your applications that runs locally on your machine will run on port 3000 or 3001 or 8080 or something like that. But actually port 3000 or 3001 is often used in development. There are other ports, of course, and every framework, they have a preference of a port, but it doesn't really matter when you write something, and I can show you that later on in the demo part of this talk. We can set out whatever port we want to use. There are very small or slim chances or any conflicts, especially if you run on your local machine, but the conflicts may arise. For instance, you cannot spin up 2 servers. You can spin up 2 servers on your local machine, but you cannot spin up 2 servers that are listening on the same port. That will cause a conflict. And again, if we have time, I can show you that in action as well. Now, let's talk about the URL, or as the cool kids on the blog call it, URI. When I was learning about web development, somebody told me this, that, the scientists, the true programmers, they don't say URL, they say URI. It doesn't really matter. It's like one of those totally idiotic things or unimportant things, but URL is an acronym. It stands for Uniform Resource Locator, and URI stands for Uniform Resource Identifier, and it's pretty much the same thing. I haven't heard any significant difference between URI and URL. The most important thing is, what is it? Well, twitch.com or google.com or whatever is a host name, right? Instead of addressing your servers using the IP numbers, which for humans is not very convenient method to type out the address, it is much easier for us to say twitch.com, for instance, or whatever. Now, there are specific pieces of software that deal with translating or mapping the host names and whatever follows after those host names in a URL to the IP address and the appropriate port and so on. So if you type in, theguardian.com, you will know, or the switches and routers along the way between you, the client, and the servers of that newspaper will know where to route your request, so it ends up on the appropriate server. And also when the server responds, they will also know where to send this request or response to, so it finds your client, right? So all of this is dealt with by software, and we're talking about milliseconds here. So in human terms, it works extremely fast, but not always. It can actually be fairly slow and creep up to several seconds of response times if you have slow servers, a lot of traffic, or aggregate traffic data from multiple sources. That could be a bit tricky from time to time. Right. So URL and URI are important. Let's take a deeper look at those, and I will use an example. I will use an example that I pulled up from The Guardian, actually, back in when the Brits were going to general election, and there were a lot of debates between Boris Johnson and Jeremy Corbyn. And so I focus on one specific article. Now, The Guardian is a huge newspaper, right? They host hundreds of, if not thousands of different articles and on different categories, and they display some ads for you, and everything has its place on that website. Now, so if we take a look at how do we access that particular article that is about Johnson and Corbyn, that would look something like this. This is the URL to that particular address. It starts with HTTPS, then you can see the 3 Ws, and then theguardian.com, which is the host identifier, and then there is a lot of other things. So let's dissect what all of that is. This is definitely a URL that you don't want to ever have to type in yourself because it's way too long, but it's quite common. If you think about it, it's quite common that you see extremely long URLs in your browser's URL input field. Now, if we take a closer look at of what we're looking at in this particular URL, so the first thing you notice is the HTTPS or HTTP, and that is the protocol schema. Now, the difference between HTTPS and HTTP is a talk in itself, but let's just say that HTTPS is the safer version of HTTP because HTTP is totally open. Everyone can listen to your to what you are listening to or reading on the internet, and with HTTPS, it's not that easy to break it, although it is possible still. Now, then you have this theguardian.com with this 3 Ws, which was more common back in the days. They are not that super important now. Now most servers would allow internet traffic in even if you omit those 3 Ws, but that needs to be configured actually on the server. So that is the host identifier, and then you have this colon 80 or 88, which is the port number, and this is actually not shown in this example. If you look at the URL itself, you don't see that after the host identifier, and that is because 80 or 88, as I said before, are default ports for all internet traffic. So the server will know what port to direct to. You basically say that everyone that doesn't have a specific business, they go through the main door, right? So let's make that comparison. And then the interesting thing shows up, right? Because then you have a slash, and then it says something like politics/live/2019/nov and so on, right? And that is the path. That is like a physical location on where this particular resource is actually located. And if we take a look at this really closely, then you see that after November 19th, which is probably the date, you can make that out. It's November 19th, 2019, right? Then you have something that says general dash election dash 2019 dash NHS Labour Conservative Stories Corbyn Johnson yada yada yada, right? And then it ends with TV debate dash Brexit, and then you have a question mark, right? But let's focus a little bit what comes before the question mark now. That is, this long name is the name of the resource. It's the title of the article itself, right? So that is probably part of the actual title. We call it a slug, actually. It's an identifier of that particular resource. This is the article that you want to read. So by passing it in the URL or as part of the URL, you tell the server what article in this case you are interested in. Or if you abstract away from the domain, you will say, what resource am I actually interested in? What do I want you as a server to serve me? And then we need to take a look at what happens after the question mark. The question mark is really important, actually. Now, you've probably seen that question mark. Perhaps you haven't paid attention to it or care about what it is and what it does, but it's quite often present on the URLs. And whatever comes after is a query string or a query parameter, and that is a key and value pair. In this case, it says page equal, so the key is page, and whatever comes after the equal sign is the value. And in this case, it's a very weird value because it says with :block and then a long number, then an @ sign, and so on, right? And to be honest, I don't know what it does. I am not an admin of those Guardian servers. I do not know what technology they are built on or what this could possibly mean. And this is not what this talk is about. But the only thing I know, and the only thing you should care about, is that by passing in this key and value, we are somehow directing the server to do something. What it is, I don't know. But this is a value that will be passed in and used by the server in one way or another. So when you look at it this way, then this URL stops being so cryptic and so hard to understand, because you can, even if it's hard for you now, if you're just beginning in this field, to understand what everything does, but you can see that there is a protocol, there is a host identifier, there might be or might not be a port number if there is a colon, and then you have a path, and then if you can spot this question mark, there are some query params, and you can pass in multiple ones. In this case, there was only one query parameter, but you can pass in multiple ones with a double end sign, or is it a simple end sign? I don't know. I can't remember. But so you can these parameters can be quite long, query parameters. Right. So the protocol schema is always identified by this colon and 2 forward slashes, and it tells the client or the browser how to access the resource. So web client is one term that we can use. A web client can be a browser, but it doesn't necessarily have to be a browser. It could be another piece of software, actually. And in this case of this URL that we were looking at, the web client was using the Hypertext Transfer Protocol, or HTTPS, or HTTP, to make a request. But there are other URL schemas, and some of them might be familiar to you, some don't. FTP is one. Mail2, which is used to send off emails, is another one. If you use version control, you might have seen Git addresses that using git : and 2 forward slashes. There's another one that is very interesting that we will be covering in the bootcamp later on, and that is WebSockets Ws Protocol. That actually flips the entire idea of request response to have a full duplex open connection between two hosts or two computers on the internet. And there are also always secure versions of these URL schemas. Right, or the protocol schemas, right? So, and the host identifier, again, already covered that tells the client and you know where the resource is hosted or located, and it's also used by the application to create those packages and address them properly and send them off later. We already spoke about the port number. It is not. It is only required if you're not using the default port. You don't even have to know about this as the end user, because most of the time you actually use the default port in your everyday use of the internet. So don't worry about that one. But if you're a developer, you might want to open up your server for various types of communication, and you can connect that with different ports. And then, of course, the path, it shows what local resource will be is requested. And again, this is also an optional part of the URL, because you don't have to pass it in, right? You can also, if you don't want to access a specific article on the Guardian servers, you can just type in theguardian.co.uk, I think. So you don't have to pass in any paths if you don't want to. And then, of course, as I mentioned, the query string is also optional because it is made up of query parameters, and you only use it when you actually want to send off some data to the server. And most often you don't type that in as a user. That is being done for you when you like click a link or a button or send off a form and things like that, right? So that's where query strings are often used, but you can use them manually if you want, and I'm going to show you an example of that in a second. So what did we learn about today? Well, hopefully something. We went over the protocol, the requests. We spoke briefly about the difference between front-end versus back-end, and also the full stack. We spoke more about the internet protocol. We mentioned and scratched the surface on that, and also on the hypertext transfer protocol and the URLs, or URIs, if you want to call them that. So that's what I had in store for you in terms of my slide deck. So let's just get this one out of the way for now and do a little bit of coding and see if we can get that off the ground as well. See if we can get any clever by doing a little bit of coding. So let's just clear up my console, cd into the Craft Academy demo folder, and I'm gonna create a small little application for you that will spin up a server on our machine, and we'll show you an example of how we can serve some HTML, a very small thing. And if you want to tag along, just let me know in chat if you want me to stop or go slower. But we will make use of Node.js and a package called Express.js and see if we can get that off the ground and actually serve a little bit of data. Okay, so I'm gonna make a folder. So I'm gonna say mkdir, and I'm gonna call it Node app, or my first Node application. Right, so I'm gonna cd into this, and here I will initiate some Node. So I'm going to initiate a yarn project. Perhaps you guys are used to npm. others of you might be used to Yarn. I prefer Yarn myself, and Yarn is a package manager for Node, and we're going to use some external packages like dependencies in order to get the functionality we want, which is basically to spin up a small server. So I'm going to say yarn init, and I'm just going to pass in the flag saying y, which means that Yarn will not ask me any questions. I will just answer yes to everything that he wants me to do. So now if I do a tree dot, that with the only thing we have in this folder is a package JSON. We can also, or you guys can do this by saying ls, that lists all the files that are present in this particular directory. Tree is something that needs to be installed on your computer, so I have it installed on my MacBook. you probably won't be able to do this command unless you have installed it. So let's now say that we want to add a few dependencies, and the only one we actually need is Express. So I'm going to say yarn add Express, and that will install the Express package together with all the dependencies that Express requires, and we can see here that there are quite a few. So let's do that. I'm also going to say yarn add dash capital D nodemon. Nodemon is a node runner that allows for something that is called hot reloading, which basically means in its simplest form that I can add a little bit of code to my application while it is running without me having to stop and restart the server, because it's a bit tedious actually to do that. I usually add nodemon to my small projects, even if they're very small. And as you can see, there are quite a few dependencies to nodemon as well. So if we now do tree dot, you can see that we have quite a few files in our tree. Now, if we do ls, you can see that we have a package JSON which was created for us by Yarn, and then we have the Yarn lock. But then we have another one that is called node modules, which is the big one. Node modules is the folder where you install all the dependencies. And for those of you who work with version control, just want to say that it is extremely important that you exclude node modules from your version control, because otherwise that will be way too big for you to push up to any meaningful place where you can host your your code, like GitHub or Bitbucket or whatever. Anyway, let's pop this open in our code editor, and I'm using VS Code. That is the best way for me. So I can see node modules, I can see package JSON, and I can see my yarn log here. All right. So I'm going to create a new file, and I'm going to call it server.js. And in my server.js, if we open this one up here in our editor, let me see if I can make this a little bigger for you. Can I do that? Yeah. I hope you guys can read this. Right. So here, I'm going to just spin up a very, very small and simple application. So I'm going to say const express equals require the express package. So I'm going to say require express like this. Okay. And then I will just say const app, which will be the application. This is like best practice just to call it app. You can see that many people do that actually. And so we're going to say an app is an Express application. So Express is a function in itself. So we are instantiating a new instance of Express, which is not exactly the correct term, to be totally honest, but let's stick to that now. And then I'm just going to say const port, and I'm going to set that to 3000, like this. And so the next thing I want to do is to say app listen at port, which is 3000. And then once you have listened, you can just say something like, you can say console, console warn, and just say server is up and running. Server is up and running. Actually, if I change this to string literals instead of quotes, I can also on port and then string interpolate the port like this, right? Perhaps this is interesting enough. Okay, so this is the bare minimum. Well, right. Oh, wait. Oh, I forgot us one parenthesis. Sorry. So there we go. Right. Those parentheses, always a hassle, right? Okay. So this is the bare minimum that we need, and we can spin this up by just, well, we can't spin this up yet. I actually need to add a script here to my package JSON. So I'm just going to say scripts, and I'm going to say start, and that would be node mon server JS, like this. And now I can spin this up by saying yarn start. Right. And now it says server is up and running on port 3000, which means that in principle, we could go to our browser and start and just say localhost 3000, like this. That's the only thing we need to do. Now, unfortunately, there's nothing to show because we haven't configured our server to actually do something when we access it. But this is, in principle, an application. But let's not settle for that. Let's have this app actually do something for us, right? So we could say something like this. Let's say that we want to just display a very basic HTML page saying hello world. We all have to start with hello world sometimes, right? So if I would say app.get, now, oh, sorry, app.get, like whenever this application gets or receives a GET request, and I haven't spoken to you about HTTP verbs, but for now, let's just stick to it, that one of the basic type of requests that we are making to a server is a GET request. So we are getting a resource, right? And let's say that the GET request we are getting is an empty one. We do not serve any parameters. We don't have to provide any path or anything like that. We just say a basic / or even we can omit that slash also. Let's say that is what we are getting. And so then we want to deal with this request response cycle, right? So we will allow this function to take one other argument, which will be a so-called callback, and that callback, and let me just type this up as an arrow function like this. This callback will take two arguments. One is called request, and the other one will be called response. And here we will execute some code whenever this route is being invoked. And so I will just say that the only thing, we don't care about the request itself for now, at least not in the first iteration. What we want to say is that we want the response. I always mix it up in this demo, always. I've been running this demo several times, always make the same mistake. Not the request, but the response. We want the response to send something. So we just add this or invoke the send function on this, and we wanted to send some basic HTML. Let's just say h1 hello world, and then close the h1 tag like this. And that's it. That's the only thing we want to do. So in principle, if I now reload this page, I should see hello world. That is as simple as it can get. Hello world is being displayed. If I try to do something else, like you know, whatever, like if I do / whatever, that will not work by any way, because there is no such route. The application simply doesn't know what to do with that sort of request. But if I just call this hello world, then we are good to go. Or the main path, we should see hello world. Now, I spoke to you guys at length with this question mark, what it does, right? So perhaps we could make use of that. So here I'm going to say let name equal request, and this time it is actually request query. Remember, I called them query parameters. We're going to say query dot name. So I'm going to send off a key value with my request, and then I'm going to change these simple quotes to backticks. So they are called string literals. And now I don't want to say hello world. I want to say a $sign and 2 curlies, open and close curly bracket, and I'm just going to interpolate the name here, right? And since I have NodeMon, I do not have to stop and restart my server. That is done automatically for me. So if I now, and I don't know if you can see that on the recording, but if I say question mark and then say name equal Thomas and send this off, the output will actually be hello Thomas. And that's good. That's awesome. So now we can have dynamic content. So we could say hello Twitch users. Hello Twitch users. Or we can say hello prep course students, and so on, right? And this is one type of parameters. There are others, but we will not dwell on that in this demonstration. We're just going to stop here and be happy with that. Of course, let's figure out what happens if we don't send anything. We just say name equal and choose to send off an empty string. Then that is exactly what will be displayed. It will be empty. And what would happen in this configuration if we don't pass in any parameters? Then it will say hello undefined. And that is, of course, not the appropriate behavior, but that's exactly what we've told the computer to do, or the server to do. We haven't told him what to do in case there is no name. So we could do that. We could say if name, then we send this off. Otherwise, we send off something else. So we could say else, and then response send, whoops, like this, and we could say hello strangers. Now we can do h1, and we can say hello stranger, like this, and then just close the h1 tag. Like this. Right. So now it will say hello stranger, and if I now pass in name Thomas, it will say hello Thomas, right? So we fix that behavior. But this is, of course, a very trivial example, so don't take it as a ready-made solution in any way. But this is more of a web application than just a website. Now, I personally define websites as fairly static, serving servers, static sites, whereas web applications are called, in my opinion, websites become web applications if there's any dynamic component to it. And in this case, one could argue, even in this very, very trivial form, that we are actually creating some dynamic content, right? Because we are changing the behavior of this controller, of this application, based on what sort of data we are being served or fed with from the client. So that will do it for me. If there are any questions, I always read my chat, but you can always reach me at thomas@craftacademy.se, Thomas with an H actually. And if you check my schedule, you will find some other demonstrations and demos and workshops coming up. But for now, thank you very much for tuning in, and I see you around. Thanks.